Hello, my P4 students. How are you all? Great. It's good that you're doing well. Okay, so today we will go back to our lesson about gravitational force. And after we will review, no, we will wrap up our topic about gravitational force, and then we will answer one drill in our workbook. Okay, so please be ready and attentive. Okay, but before we wrap up our lesson, let's watch this video about gravitational force to understand, to have a better understanding about
Gravitational force. Why do you weigh less on the moon? Hey, what are you doing? It is not possible. You cannot fly on Earth. Please listen. Look, I had warned you. Now, why don't you try the same activity on the moon? There, you will weigh much less, and thus, you can fly short distances. See? I was correct. Do you know why you weighed less on the moon? To understand this, we need to first learn about weight. No, not those weights. Weight is the force with which an object is pulled towards the center of the Earth or any other celestial body. This force is called the gravitational force. Greater the gravitational force exerted by the celestial body, more will be the weight of an object present on it. So, does this mean that the moon exerts less gravitational force than the Earth? Bingo. You are right. But do you know why? This is because gravitational force is directly proportional to the mass of an object. Greater the mass, greater will be the gravitational force exerted by it, and thus, more will be our weight. As the moon has lesser mass than the Earth, it has a weaker gravitational pull, and hence, we weigh less on the moon.
All right, so that's it. If you remember our discussion last time, we had an example about your weight here on Earth and the difference with your weight when you go to the moon, right? Okay, so example, if your weight here is 480 Newton, if you go to the moon, your weight will only be 80 Newton. Okay, so our weight changes depends on our location. Okay, not like our mass. Our mass will always be constant. Okay, regardless of the location. Okay, so gravitational force is a force exerted by the Earth that pulls everything to its center. And the mass of an object is the amount of matter in it. Okay. And the SI unit of mass is kilogram or kg. Next is the weight of an object is the gravitational force acting on it. And the SI unit of weight is Newton or N. Okay, so the force, the more mass the object has, the more it resists changes in its motion. Okay, so the mass affects the motion. Okay, affects the motion. The more mass an object has, the more weight it has, of course. Okay, for our mind map, we have gravitational force, and we talked about effect of gravitational force, and then mass, effects on motion, weight. We use a spring balance, no, to measure weight, and compression balance. And to measure the mass, we can use electronic balance. All right. So that's all about gravitational force. Okay, so this time, let's go to our activity book. Okay, please get your activity book and open it on page 63. 63, right? 63. Okay, so let's answer number 1. Fill in the blanks with the correct words. Okay, so the answer keys are here. Okay, so these are the keywords. Okay, gravitational, spring balance, weight, same, kilograms, newtons, mass, and greater. Okay, letter A. The blank of an object is the quantity of matter in it. What is it? Yes, that's right. It is the mass. Okay, mass. Please write mass. Okay, so the mass of an object is the quantity of matter in it. Okay, so the more matter on an object has, the greater or lesser mass it has. Of course, greater. All right. The greater the mass. Letter B, the blank of an object measures how much gravitational force is acting on it. What is it? Yes, that's right. It's the weight of an object. All right. Is right. Letter C, blank force is the pulling force on all objects towards the center of the earth. What is it? Yes, you're right. It's gravitational. Okay, gravitational. All right, please write. Gravitational force is the pulling force on all objects towards the center of the earth. Letter D. The unit of weight is, remember, it's Newton. Okay, newtons or N. For mass is kilograms. Kilograms. All right, kilograms or kg. Next, letter F. A blank can be used to measure weight. What do we use to measure weight? Yes, it's a spring balance. Yes, spring balance. All right, spring balance. Next, letter G. The mass of an object is the blank wherever it is, but its weight can change. It's the same. All right, same. No, our mass is constant wherever we are, wherever we go. Okay, wherever we are, but the weight changes. All right. Okay, so that's it for number 1. Now for number 2. Okay, let's move to number 2. All right, so here we have instruments. Okay, these are the instruments. Okay, so name of the instrument. Okay, so let's name the instrument here. Okay, so for this one, I know that you know already. Okay, for this one, this is, what is this? This is electronic balance. All right, electronic balance. All right. Okay, so this is electronic balance, and we use electronic balance to measure the mass. To measure mass. All right, to measure mass. Okay. All right. Okay, so for this one, I will write here only the function, and I will let you write the name. Okay. This one, to measure weight. All right, to measure weight, and same with compression balance, to measure weight as well. All right. Okay, for this part here, name of instrument, I want you to write it by yourself. Okay, so check your book and write the name of these two instruments. All right. Okay, so that's all for today. See you again next time. Goodbye.